Alright friends, welcome back. In this video I'd like to go ahead and take a third day for section P.5. There's a lot of things in that section, so it's good to take a couple days to take a look at that kind of stuff. So in this video specifically, what I want to do is talk about one topic, and that topic is this idea of a complex fraction and how to simplify it. Okay, so real quick to start off with the definition, what is a complex fraction? I feel like a lot of people look at this word complex and they start to kind of think to themselves like, ooh, that must mean that this is super complicated or that it's difficult or challenging or something. And it's not really the context that you want to go with, right? So a complex fraction is more of like the context of like a building complex, like an apartment complex or something like that, where it's a larger building made up of a bunch of tinier buildings, right? So that's exactly what a complex fraction is it's a fraction that's made up of a bunch of tinier fractions, okay? So to read the definition here, it says a complex fraction is a fraction that also has a fraction in the top or bottom or both, okay? So you can see a couple of examples down below here. We've got fractions within fractions, right? So we want to kind of take a look at how to simplify those things. And here's just a couple of really quick guidelines for being able to do that. Now, I want to talk really briefly about what I mean when I say condense or combine, because that's the first two guidelines here. We want to condense or combine the numerator and then condense or combine the denominator. What I really mean there is what you're going to have is like a fraction minus a fraction or a fraction plus a fraction. You just want to go ahead and do what we did in the previous video where we were adding and subtracting rational expressions. You want to combine it into one, okay? So when I say this, I mean into a single fraction. So you're going to take everything in the numerator, you're going to combine it into a single fraction, do the same thing for the denominator, and then after that you're going to perform a step that I'm going to go ahead and in this notes call flip and multiply, which if you have learned in a previous algebra course, whenever you divide by a fraction, that's equivalent to multiplying by the reciprocal. And that's exactly what we're doing here. Okay, so multiply by the reciprocal if you have heard of that before. Okay, that's exactly what we're going to do for these problems. And then after that, some familiar steps here, stuff we've been doing all week. We've just been canceling and then simplifying if we need to, okay? And so these are the basic guidelines for being able to simplify a complex fraction, and so I want to go ahead and demonstrate those with a couple of examples here. So the directions are simple. It says simplify the given complex fraction, and so how I'm going to do this today is I'm going to go ahead and devote some color to my numerator and denominator. So separately, I'm going to go ahead and color my numerators in blue here, and then color my denominators in green, because later on you'll see in these examples that they tend to have some steps to them, and I just want us to always be clear about what we're dealing with. So I'm going to stick with these colors here as I go through these examples. Okay, so I'm going to do my numerator in blue, and what we need to do is follow the guidelines from the guidelines up there, right? We need to go ahead and condense our numerator into a single fraction. And so this is exactly what we did in the last video. We can always put 1 over 1, and then whenever we're trying to get a common denominator, we need to go ahead and introduce factors to our denominators that are going to get them to be the same. And whatever we introduce to the denominators, we also have to introduce to the numerators here. And so if you're taking a look here, I've got x over 2 minus 1 over 1. Okay, I can get a common denominator there by going ahead and introducing a factor of 2 to the numerator and the denominator of that second fraction there. Okay, so I can go ahead and condense this into a single rational expression by saying x minus, that's 1 times 2, or in other words, just simply 2 there on the top. And again, I said I was going to stick with my colors there, so let me try that again. So that was going to be x minus 2 over 2. Condense that into a single fraction. Okay, in the denominator, I'm going to have, it looks like just a copy of x minus 2 there. All right, and remember that you can always take any quantity and write it over 1 so that it maybe looks a little bit more reminiscent of an actual fraction there. So I'm going to go ahead and do that. I'm going to say x minus 2 all over 1, and that is condensing the denominator into a single fraction. Okay, it's at this point that we want to go ahead and perform the guideline number 3 from up above, right? What we want to do is we want to change this operation, this fraction bar, which does represent an operation. Remember, that's just simply division. We want to change that from division to multiplication. And in algebra, we have a rule that says that that's possible, but as long as we go ahead and multiply by the reciprocal of this fraction right here. Okay, so as long as we go ahead and flip the fraction that we're dividing by upside down, then we can go ahead and change that division to a multiplication here really quickly. Okay, so I'm going to go ahead and do that. I'm going to take what was a division and make it into a multiplication, and we can do that as long as we do it by the reciprocal. So that green fraction, I'm going to turn it upside down, call that 1 over x minus 2, and then go through, right? So the guideline number 4 from up there says that now we want to go ahead and cancel. So if we see any factors that they have in common in the numerator and denominator, we're going to scratch them out. So here I have an x minus 2 and another x minus 2. Those are going to cancel for me. And the only thing left in the numerator is going to be an extra factor of 1. And the only thing left in the denominator is going to be an extra factor of 2. And so this is going to simplify down to simply 1/2 as our final result. Okay? Really quickly, we should go back to the very original problem and look for any sort of domain restrictions here. And so if you look at that green denominator, that says x minus 2. Remember that the denominator is never allowed to be equal to 0. All right? So if I go ahead and set x minus 2 not equal to 0 as a mini equation, and then just simply add 2 to both sides, what we would see here is that x is not allowed to be a value of 2. And so I'm going to go ahead and tack that onto my answer as a domain restriction here. It's not necessarily something that the directions asked us to do, but it's always something that we need to kind of think about, so we might as well get some practice with that. Okay, so there's a quick example of that. Let's go ahead and take a look at that one more time here. Okay, so here in this next example, again, I'm going to follow my coloring convention here. I'm going to go ahead and stick with my numerator in blue, and I'm going to go ahead and write my denominator in green. Okay, now, again, same process here. I'm going to follow the same guidelines. But we are going to have to do a little bit more work in this numerator and in this denominator separately. So let's go ahead and take a look at that. I'm going to go ahead and write to the two fractions in my numerator as, the 5 over y. And I'm going to leave some space. And then I'll go ahead and write my 6 over 2y plus 1. Okay? Now, again, this is what we did in the last video, so I'm not going to dive too deep into why I'm doing this, but if you want more background on that, you could check out the previous video to this one. I believe that was P.5 day 2. What I'm going to do is I'm going to start to get a common denominator now, which means that I'm going to need to introduce some terms to these denominators to get them to match up. And so if I look at that first fraction, it just has a y in the bottom. I need to introduce a copy of 2y plus 1, which means I also need to introduce that to the numerator here as well, 2y plus 1. In that second denominator, it's missing its copy of y, so that is something I'm also going to introduce to the numerator. All right? And so there's just a little bit of work with working with my blue numerator there. I'm going to go ahead and move on to my green now, my denominator, because I've got a fraction that looks like 5 over y. That'll leave some space, minus, and then I've got a 4. Remember, we could always write that as a fraction, 4 over 1. And then we can go ahead and play that same game. We're going to go ahead and introduce what the other is missing. Well, if I find a common denominator here, that's just going to end up being y times 1, which is just simply y. And so it looks like that first fraction is ready to go, but the second one will need a copy of y in the denominator, so I'll also introduce one to the numerator. All right? And now we'll go ahead and simplify here. So in the my numerator, in the what's in blue, I have a common denominator of y times 2y plus 1. And then in the numerator, I'm just going to go ahead and write out what I've got. I've got 5 times the expression 2y plus 1, and that's minus 6y, because that was 6 times y. Okay, that's the numerator there, and I'm going to go ahead and write this over our denominator, which again I'm going to do in green here. So that's just simply going to be a common denominator of y, and then in the numerator I just simply have 5. Actually, let's see, that was a plus 4, wasn't it, from before? So I should say that that's a plus. I apologize. There we go. Fix that up. All right, so 5 plus 4y. All right, and so it's at this point that we would just want to simply go ahead and simplify as much as possible. So what I'm going to do is I'm going to go ahead and go back up to my numerator, and I'm going to hone in on the numerator of my numerator, which seems a little bit awkward to say. But what you'll notice there is that I have a 5 that I can be distributing in to both terms there. So let me fix that so I can... There we go. Demonstrate that properly. And so let's play with that, right? So a 5 distributed in, that would simply, I'm just going to do this off to the side. That's going to be a 10y and then plus 5. And then I have that minus 6y there. Okay, so if you combine some like terms there, what you're going to end up getting there is just simply 4y plus 5 is your numerator there. All right, so we'll hold on to that. The denominator there in green, that doesn't look like it needs too much work, although one thing I will do is I will go through and rewrite my stuff in standard form, right? So the only thing that I want to kind of point out here is just this numerator right here. When you write something in standard form, that just means you're writing it so that the variable comes first and the constant comes last. So I might write this as 4y plus 5 when I move on to my next step. And speaking of the next step, we are going to go ahead and proceed with our guidelines from up above, which means that now that we've condensed the numerator into a single fraction, and same thing with the denominator, I'm going to change this operation of division right here to multiplication by the reciprocal, okay? And so on my next line down here, I'm going to go ahead and have my blue fraction in the top, which remember we simplified that numerator to 4y plus 5 all over y times 2y plus 1. And I'm going to change that big division to a multiplication by the reciprocal of what I have on the bottom there. And so if I flip that upside down, then I'm going to have y on top and what we called 4y plus 5 on the bottom, because remember we flipped the direction of that, right? And again, you could start to see now why I've done that, because now when we proceed to guideline number 4, which is to now cancel, we see that we have a couple things that we can cancel here. Specifically, I've got some factors of y that will cancel for me, and you also have a binomial factor that will cancel in the top and the bottom. And so after everything cancels in the numerator, what's left over is just a bunch of factors of 1. And so here I'm going to go ahead and write my final answer as just simply 1 on top, and then on bottom I've got 2y plus 1. And that represents your simplified form of this complex fraction here in this example, okay? We should always look back at our original to figure out what kind of domain restrictions we have. And if you notice here, we do have a y in the denominator, and we have a 2y plus 1 in the denominator, okay? So all the denominators that I have, I'm going to circle. And then separately over here, I'm just going to go ahead and say that these denominators are things that are not allowed to be equal to 0 themselves. And that sets up a couple of different mini equations for me, and I can go ahead and solve these little mini equations for my domain restrictions. So there's really not a lot to solve there. Y cannot be equal to 0, so I'll just kind of copy that down here as a domain restriction. Y can't be equal to 0. But then if you solve this other one, I'm not going to show the steps for that, but you're going to find here that y is also not allowed to equal a negative 1/2 as your other domain restriction here in this example. So I'll go ahead and say that here as well. I am not allowed to equal negative 1/2 there as well. So always kind of thinking about your domain restrictions, very, very important to point out. But there we go. Straightforward example of applying the guidelines there. It is a little bit of work, but again, when you work with complex fractions, you're basically putting all the things that we've talked about in section P.5 all together at once. Moving on to this next example here, we have example C. We're going to do the exact same thing. I'm going to go ahead and combine everything in my numerator, and then separately I'm going to combine everything in my denominator. And you'll see here that the denominator really does not have too much for us to work with. It is an h, so I can make that look like a fraction and say h over 1. And then simply go through and, matter of fact, we might as well just go ahead and skip straight to the step where we are multiplying by the reciprocal. I think that might be the easiest thing to do here. So I'm going to go ahead and write out the numerator, the thing that's on top. So that's 1 over the quantity x plus h squared all minus 1 over x squared. And then if I'm going to go ahead and change this to multiplication by the reciprocal, then again, here's what I'm doing. I'm taking this fraction bar right here. I'm going to go ahead and change that to multiplication as long as I do it by the reciprocal, and that's going to be 1 over h. Okay, and the reason I'm performing that step first is because now that's something that I can go ahead and distribute into both. So now I can go ahead and rewrite this as 1 over h times x plus h squared, and then minus 1 over h times x squared. All right, and now if I'm trying to find a common denominator, it looks like both of these denominators already have the h, but they are missing the other factor. Okay, so I might just go ahead and introduce that. I might go ahead and say multiply both the top and the bottom of this times x squared, and then when I subtract off the other fraction here, I can go ahead and introduce copies of x plus h squared. So again, just introducing what the other was missing there is the way we want to go ahead and take care of this problem here. So we have a common denominator now. And I was missing my extra factor of h there in that numerator. So let me go ahead and reintroduce that. There we go. We have a common denominator now of h times x squared times x plus h squared. That is our common denominator. And so we're going to go ahead and now proceed to the part where we can condense all of our numerators into 1 by doing that operation in the middle. So that's subtraction. So that's going to be a 1 times x squared. That's just going to be x squared. And then minus 1 times x minus h squared. Well, that's just going to be x minus h, or x plus h squared, I should say. All right, and so now we're cooking with fire here. We have this condensed into a single fraction, and so the only thing left to do is to go ahead and simplify as much as possible, okay? And so the way that we can proceed with that is by noticing that in the numerator, I have something that looks an awful lot like u plus v all squared. And what I want to do is I want to go ahead and expand that out using one of our special product formulas from back in the day, where we said that that would expand out to u squared plus 2uv plus v squared. That's just your perfect square trinomial formula. And actually expand out that numerator and see if I can work with this a little bit more. Okay, I'm going to leave that denominator factored for now, but let's go ahead and see what we've got here, because in the numerator I'm going to have the x squared minus that was still out front, but now I'm going to go ahead and apply this formula here. So that's going to be playing the role of u as x, so x squared plus 2 times u times v. Playing the role of v as h, so I'm going to go ahead and say here 2 times x times h, and then plus whatever's playing the role of v squared, so that'll be h here. And so we'll go ahead and write it like that all over my denominator, which I'm just not going to write out. I'm just going to use some quotation marks because it would be that exact same expression right here, just putting it right there, right? We're just working with the numerator at this point. And I want you to notice what happens, right? So when we distribute this negative sign in, it's basically going to change the sign of everything. And I want you to notice what happens, right? We're going to have an x squared that's out front, x squared, and then we're minusing off x squared. So those are the things that are going to cancel for us pretty nicely. And it's just going to be what we have left over after we distribute that negative to both of these other terms here. So let's go ahead and write that. That's going to be negative 2xh minus h squared. And that's over our denominator, which I'll go ahead and write an extra copy of here because it's all the way up there or we can't see. So there we go. There was our denominator. And now why does that help? Why does that get us to a point where we are writing something simpler? Well, now if you look at what we have going on in our numerator has a GCF that we could pull out. Okay, so they have some things in common there. So if we pull out a negative h, say, for example, then that leaves behind 2x plus h. And the reason that is going to help here is because you'll notice that we have an extra factor of h in both the numerator and the denominator. Okay, and those are going to be factors of h that are going to cancel nicely for us. So if we factor those out and cancel those, then we are left with our very, very final result here, which is a negative version of 2x plus h all over x squared times x plus h squared. Okay, so that one got a little bit involved, but again, we're just applying the same guidelines as before. We're simplifying everything, condensing everything. I did skip straight to my multiplication by the reciprocal step, but that was just because if we didn't do that as a first step, then this would get a lot more complicated than what it turned out to be. So we'll go and move on to this last one here, which is part D. And there's a lot of different ways that you could handle this one, but the way that I'm going to go ahead and do this one is by splitting up that common denominator. So if you look at this, you do have the subtraction of two terms in the numerator, and it's all over the same common denominator, right? So the way that I'm going to look at this problem is by uncombining those denominators, right? I'm going to go ahead and split these up again, okay? Which is the reverse direction of where we have been, but there's a reason why I want to do that, and it's going to be clear here in a second. So if I go ahead and give both of these terms in the numerator that I'm subtracting, if I give them their own denominator of 4x to the power of negative 3/4, then what we can do is we can simplify both of these fractions individually and then write our final answer. Okay, so the numerator here, I'll have my first term, so that's the 4x to the power of 1/4, and then there's my minus, and then the second term, x to the power of negative 3/4. And then look carefully at what happens here. We're going to have some canceling going on, right? So specifically, I've got 4 and 4. Those are going to cancel nicely for me in that first fraction. If you look at the second fraction, I've got a copy of x to the power of negative 3/4 on the top, and same thing on the bottom. So again, those are going to cancel nicely for us. All right, and so now what do we have? Well, if you look closely at that first fraction, we do have a negative exponent there. And just remember what negative exponents do. They change the base to the opposite side of the fraction bar. So if what we had already up there was a copy of x to the power of 1/4, now because of that negative exponent, the x to the power of 3/4 migrated up to the top. And remember what happens when you multiply like bases. You add the exponents. So that would be a 1/4 plus a 3/4. That would be x to the power of 4/4. And we all know that's just x to the power of 1, which we typically just write as x. And so believe it or not, this whole thing is just going to simplify to. This whole first fraction is just going to simplify down to simply x. And then this second fraction right here, after everything cancels, that's just going to simplify down to negative 1/4. And so that is going to be our final answer for this problem, believe it or not. And if you wanted to, you could condense this down. You could get a common denominator here by putting 4x over 4. And then another equivalent way of writing this final answer would be the following. It would be 4x minus 1 all over 4. So 4x minus 1 all over 4 if you wanted to condense that into a single fraction in that way. So either one of those I would say is acceptable. As far as a domain on that one, because in our original numerator, if we plug in 0 for that, that's going to create a 0 in our denominator, so we'll just go ahead and tack that on as a domain restriction for that. But that is going to be it for this video, okay? So again, complex fractions are fractions within fractions, just following the simple guidelines from before of condensing everything and then multiplying by the reciprocal, canceling and simplifying. It's going to help you out a lot on these problems. So I hope that this video has been of some help to you. Please let me know if you have any questions at all. As always, have a nice day, and I will speak to you in the next one.